Hi everyone, my name is Tom Strickx. I'm a network software engineer at Cloudflare, and today I'll be talking about the anatomy of a route leak. Now, to be fair, this talk is shared between three people at Cloudflare. That is Jerome Fleury, who is the Director of Network Engineering, as well as Martin Levi, Distinguished Engineer at Cloudflare. Martin did this talk at MENOG. So what will I be talking about today? First of all, we'll dive into some internet history so we better understand where we're coming from. Then I'll also dig into some BGP route leaks that happened before. And after that, we'll dig into the main part of this conversation, the main part of this presentation, which is the route leak that happened on June 2019. Furthermore, I'll have some comments on route optimizers. But the most important thing, I think, is that there will be pictures. So first for some history, first for some context. This is March 1977. This is the early days of the internet. It's not the start of ARPANET. It's not the start of the internet. But it's still well within the early days of the internet. And at that time, only really one company, BBN and their IMPs or routers, had an IP routing table. And all of that was managed by BBN. So for all intents and purposes, it was a single company that managed the internet routing table, and that's perfectly manageable. But that's definitely not the scale of what we now have in the default free zone, where we have tens of thousands of autonomous systems, each and every single one of them individually managing their import and export policies and the way that they carry their table. And furthermore, what you'll see when I talk about the history here is that there's a single common denominator, and that single common denominator is security. Security was never really considered when the internet was built. Everything was just kind of built on the fact that, oh, I know who that network operator is, or I know who that network operator is. I trust them. So everything was just built on trust. And then when you move to the next iteration of the internet, and then you have RFC 791, where we first define IP, and let's be clear here, that first RFC is still just as applicable as it was then as it is now. And in section 3.1, the header format was defined. And one of those headers was the security field. It allowed for 16 bits of security settings, which translated to 16 levels of security, 8 of which are now reserved for future use. But I think, as we all know, unfortunately, this header is not really used in the wild by any application. Even if it were being used, nobody really abides by it, so it has no relevance. So on top of this internet without any predefined security, Tim Berners-Lee decided to build the World Wide Web when he was a researcher at CERN, roughly around 1990. Now, if you read one of his first proposals, he does consider that the exchange of information is way more important than secrecy, or if you were then to extrapolate this, way more important than security. And you again see the same thing in RFC 1267, which defines the latest iteration of BGP, BGP3. In 1991, they explicitly mentioned in their security considerations that security issues are not discussed in this memo. Unfortunately, security was considered out of scope because, again, everyone knew each other, so it was just a basic relationship of trust. But then if you look at the progression we've made from when Tim Berners-Lee first made that proposal for the World Wide Web in 1990 to what we now currently have, nothing even looks remotely alike. While previously everything was in plain text without verification, we're now in a world where more and more World Wide Web traffic is encrypted, and where we have systems such as the NSSEC that make sure that we're not being lied to. If you look at this kind of diagram that we have, is when you want to make a connection between a client and a server, you have the name, and then you have the name resolution using DNS to an IP, and then you have the IRRs, and then you resolve to an ASN. But right now we have an entire infrastructure setup which provides encryption and verification of all of that initial setup. And we now even have RPKI and IRR entries to make sure that that IP to ASN mapping even works. But Unfortunately, that security posture, that very clear security posture that we now have on the higher layers of the network, has not propagated downwards to our transport layer. And the internet as a whole remains largely unsecured. And unfortunately, that has consequences. For example, like these are some press articles we've gotten before. This is what the rest of the world will see, what the press will actually publish when the internet has a hiccup. These articles get written on a regular basis and it just kind of really happens. But I think we can all agree it's never fun when you're on the receiving end of these. So on to BGP and BGP route leaks. You know, the thing we all know. BGP has a very long and sordid history with route leaks. The first well-documented one was AS7007, in which a router bug deaggregated the entire routing table and redistributed it. As some of you may know, this caused severe impact, and as I said, it's probably one of the first well-documented route leaks. But then we have the Pakistan Telecom hijack of YouTube. Again, fairly well documented and well published in the press because YouTube, one of the biggest websites on the web, was impacted. What happened was that Pakistan Telecom was trying to limit YouTube reachability in country for regulatory reasons, and because of a mistake, they leaked that unreachability to the rest of the internet, causing the rest of the world to be unable to reach YouTube. And then you have Malaysia Telecom, which had an incident in 2015, which unfortunately was made worse because Level 3 propagated it. In 2017, Google leaked their entire table to Verizon, which caused impact to traffic in Japan. And then in 2018, you had Main One in Nigeria leaking the prefixes of Google, Cloudflare, and others to China Telecom, causing massive disturbances globally and raised some eyebrows because China Telecom was involved, so they thought maybe a government actor was involved. And then to bring it all back home, to bring it to the crux of this presentation, is in 2019 we had the Verizon route leak. So that begs the question, why do these keep happening? As mentioned before, the foundations of the internet are built on trust. Trust can be broken and mistakes can be made. We need better systems in place to protect ourselves against this. Unfortunately, this timeline also only lists a very small selection of high-profile route leaks. It's fair to say that a route leak happens on a daily basis. So these can definitely happen to you, either on the receiving end, or probably even worse, on the sending end. Like I've said, these leaks keep happening and keep impacting networks across the globe. While the one in the tweet is very amusing, it's still very impactful. And it shows something else as well. This isn't just someone making a typo and announcing a /12 on IPv6 instead of an internal /127. This is someone's lab. Or something like it anyway. So it's entirely possible for anyone's perfectly internal network to suddenly leak to the entire rest of the internet and impact so many networks. So now that we have some more background and hopefully a better understanding where we've come from, what actually happened on June 24th, 2019 at 10:30 UTC? Well, as you can see from a couple of snapshots from from press articles, on that day for almost 2 hours, the internet had a heart attack. A very high-profile heart attack even. In those 2 hours, multiple high-profile websites became unavailable. Unfortunately, a lot of them were using Cloudflare services, or at least that was what was being published. So a lot of what we do on a day-to-day basis as network operators is highly visible to the rest of the world, or at least much talked about when it goes wrong. So while Cloudflare was the one in the press, this screenshot from Strickx, for context, Strickx is a popular network monitoring system, shows the massive extent of this issue. Many more edge networks were being impacted by this leak. It's not just Cloudflare. But if you just look at Cloudflare, you'll notice that the impact was roughly around 15% loss. You can translate this to either being 15% of our routes were deaggregated and leaked, or 15% of our eyeballs were worldwide were not able to reach our prefixes. So how did we as Cloudflare fix this? Or how did we try to mitigate the impact from this route leak? As you all probably know, and as you all probably can predict, this was not resolved with automatic detection. This was not resolved with machine learning or artificial intelligence. It was resolved by one of my coworkers making a phone call to a network engineer at DQE in Pittsburgh. And it took a couple of phone calls. It's not one of those things that was easily resolved. Again, as you saw, it took almost 2 hours to resolve this. It took some convincing to make this all go away. And surprisingly, no mitigation had been put in place by Verizon during those 2 hours of outage. It eventually took us over a week to even get an acknowledgement from the Verizon NOC. So I've mentioned BGP leaks now, but really, what is a BGP leak? Well, it turns out that we've actually got a very good definition of what a BGP leak is. If you read RFC 7908, while it being a recent document, it's from 2016, it puts into words a well-known problem within the internet community and helps define that issue, which again allows us, the operators, to get together and come up with solutions to the scourge that BGP leaks are. So while we now have some idea on the background of the incident and a high-level overview of what actually happened, let's dig in a bit. Let's have a look at one of the leaked routes. If you look at the AS path for this prefix, you'll notice a couple of things. There's multiple tier 1s in the path, but not in a connected chain. Verizon is advertising to Telecom Italia, but Verizon isn't receiving that route from another tier 1. No, they're receiving it from Allegheny Technologies. Allegheny Technologies is an iron smelter in Pittsburgh. While they're traded on the New York Stock Exchange, I think we can all agree they're not a tier 1 ISP. And then you have DQE, which is the ISP that we called to eventually resolve this issue. And then you have Cloudflare. This by itself, I think we can all agree, is already very broken. But there's something else very wrong, and this is going to be partially or part of the main talking point of this talk, is if you look at the ROA that Cloudflare has signed for one of its prefixes, you see that we've signed it for a /20. If you look back at the previous slide, I tried to bring your attention to the fact that the route we're seeing here is a /21. So if you again look at the ROA that Cloudflare signed for their prefixes, you'll notice that that prefix is signed for a /20. And one of the things that an ROA also allows is to sign it for a max length. In this case, we have signed it for a max length of /20. So that means that the only valid incantation of this prefix in the default free zone should be a /20, because again, as you can see, the prefix is signed to be a /20 with a max length of /20, with an ASN of 13335 assigned, which is the main ASN for Cloudflare. So that means that anything that doesn't match those very specific requirements should be considered an invalid prefix. But as you've seen in the previous slide, a /21 was seen in the default free zone. So I think we can, again, all agree that something has gone very wrong indeed. So once this very bad route had passed Verizon, it's too late. Many other tier 1s just blindly trust Verizon and redistributed the bogus route to all their customers and peers. What you may notice though is that some important tier 1 providers are missing here. We'll get back to them later. But also note that where we've added not Cloudflare, even though it's our AS number, AS13335, it's most definitely not us. We don't connect to the internet through that chain of AS numbers. So the route all of these networks are suddenly seeing and taking to reach Cloudflare isn't actually going to Cloudflare. So at the end of all this, we've written 2 blog posts about it. The one I wrote, we published an hour after the incident and gives a general overview of what happened, which actions we took, and what was about it. We made it public to the world, what we saw happen, and how we resolved it to make sure that we're as transparent as possible throughout this entire incident. In the other one, which followed about 2 days later, Martin takes a deep dive into the incident, identifying what exactly went wrong, where it went wrong, but more importantly, what we can all learn from it, so we as a community of internet operators can be more secure. To make that happen, he also included all the script used to show leaks, so you can, as an operator, use them to check for leaks for your own prefixes, but more importantly, you can also reproduce everything we've said in those blog posts. These scripts allow anyone to run an analysis of any route leak, but more importantly, of the route leak that happened in June. So you can come to your own conclusions, figure out everything that you want to know about what really happened at that time. But it was very clear to us at the time that this was definitely not just us being impacted. If you look at a bunch of other content providers, you'll notice that their prefixes were unfortunately also being both deaggregated and leaked. So you may have seen that I've only really been talking about IPv4. So what about IPv6? Well, fortunately, Allegheny is an IPv4 only network, so they only really leaked our IPv4's more specifics. But that's not the whole story. If you look at our IPv4, IPv6 traffic ratio to Verizon and its subsidiaries, you see a clear uptick during the incident. To us, this is likely the Happy Eyeballs algorithm at work. Happy Eyeballs has been put in place as a protection against IPv6 failures because still we consider IPv6 the new kid on the block, even though it's been around for at least 20 years. We want to protect against it. So what Happy Eyeballs will do is it will prefer IPv6 connections, but if those IPv6 connections fail, it will fall back in a safe manner to an IPv4 connection. But apparently this also really works in the opposite direction, where it will make a IPv4 connection first and fall back to IPv6. So apparently Happy Eyeballs is also a very good safety mechanism when it comes to IPv4 failures. So we now kind of have an understanding of really what happened and which problems we've encountered. So maybe let's touch on solutions. One of the first solutions some of you may think of is Peerlock. So let's have a quick chat about Peerlock. With Peerlock, you reject routes from your customers that contain another tier 1. If you are a tier 1, such as, for example, in this case, your Cogent, you have no reason to accept a route from Verizon that also contains level 3 in the path. But again, like even if you're not a tier 1, you can and should apply this to your customer sessions. Fortunately, Job Snyder's did a much better talk about this than I will ever do at MENOG, and his slide deck is linked in the slides. So if you again look at this from a directly connected perspective, by the sheer nature of being a tier 1, that kind of means that you're directly connected with all the other tier 1s. Because that's the case, that means that Cogent should never be accepting a level 3 prefix through a Verizon session because they're directly connected through level 3, so they should only ever accept level 3 customer prefixes through their level 3 sessions. So Peerlock in and of itself is a lot easier to implement for tier 1s because due to their sheer nature, as mentioned, it's just an explicit AS path filter away. For content networks such as Cloudflare towards transit, it's still doable, but it might require some more effort and thought, but it's definitely very much doable. IXPs, on the other hand, it's not as easy. It's a lot harder, but fortunately, we have systems such as PeeringDB that added a new feature called Never on Route Servers, which hopefully make this implementation a bit easier. So that's one solution. Now let's talk about the main cause for this incident. BGP route optimizers. Why did a BGP route optimizer make this incident so much worse? I've touched on this before during one of the talks, but BGP optimizers use this technique that de-aggregates received prefixes into smaller prefixes to better load balance traffic over multiple egress links. If you leak these fake routes, you will attract all the traffic for them, due to BGP always preferring more specifics, unless your upstream filters them. And as we saw during the incident, nobody has the capacity to suddenly be the main transiting point for a large volume of internet traffic. This is a screenshot of BGP play, and you can see the /21 here. That route is invalid and not actually advertised by Cloudflare. If you see like the timeline is slightly before the actual incident, you see nothing in the BGP routing table, and then suddenly this spike of BGP updates that contain that /21. That is when the incident happened. That is when that very invalid route suddenly reached into the default free zone. So the main cause of this, as mentioned, are BGP optimizers. We don't agree with BGP optimizers and how they work. And we definitely don't believe that BGP optimizer companies know what they're doing, which also means that they really shouldn't be publishing best practices for BGP filtering. What we do believe is that BGP optimizers cause fake routes. What made it even worse is that we have within our community a well-established community called No Export, which basically means that any prefix that has that community attached will never be exported to a different autonomous system. While BGP optimizers apparently, or at least some of them apparently have this feature, it is disabled by default. That just kind of means they're insecure by default. And that is, for a modern company, to us anyway, very ridiculous. And if you then look at the very specific company that made the route optimizer that caused this incident, Noction, their response unfortunately left a lot to be desired. No ownership was taken for this incident and blame was shifted. What made it even worse is they pointed to a bunch of other incidents that were not their fault, as if suddenly that absolved them from any blame. So again, let's talk solutions. So I've touched on this before, but RPKI is definitely one of those solutions. I'll agree it's not the end-all solution to this, and we'll come back to that. But I think it's very important to touch on the fact that the more networks do RPKI route origin validation and the more networks that do RPKI signing, the better we'll be. But what else can we do? Well, what else we can do is, first of all, apply best practices. Sign the Manners initiative. And part of that will be IRR filtering. Again, I'll be the first to admit that IRR filtering comes with multiple hurdles. There's no straightforward one deploy fits all method for IRR filtering. No given time frame on how often you should update them. So many IRR databases, so you don't really know which one to trust. Which automation framework do you use to publish the prefixes that are being generated from your framework? How do you push that to your routers? How do I tell my peers or customers I'm not accepting their routes because there's a missing IRR entry or their IRR entry is wrong? And so on and so forth. But again, I think it's important to say that the past 2 years and the next coming years will be big for routing security. For example, for Cloudflare, we signed most of our prefixes, over 90%, which include our DNS resolvers, as well as our 1.1.1.1 resolver. If you then look at tier 1 providers, is NTT is now treating ROAs as IRR route objects and is dropping invalids. They're joined by AT&T, KPN, Telia, GTT, and many other networks. Over 100 networks have now joined the mutually agreed norms for routing security, Manners. And again, as a side note, Aaron allows integration of its contract into RPKI software workflows, and it has renewed its review of legal issues. I highly recommend you go to isbgpsafeyet.com to have a further read. Now, We've touched on all these big issues. Now let's have a quick detour into Africa. Seacom is one of the ISPs in Africa that does deploy RPKI route origin validation. Unfortunately, due to the legal concerns they have regarding the ARIN Trust Anchor Locator, the ARIN TAL, they do not use it, which means that the Cloudflare ROAs that we've signed, unfortunately, are located in ARIN, which meant that the more specifics were not being rejected. They were not actually seeing the issue. The only thing they saw was unverified /21s. This only showcases what we need to lower the legal barrier for RPKI adaptation. Christopher Yu and David Wishnick wrote an excellent paper for Penn Law which showcases this. I highly recommend you send this to your legal departments and or have a read for yourself. So why should you deploy RPKI route origin validation? I hope this picture should tell you all you really need to know. With filtering, as you can see for AT&T, for example, there's no impact. AT&T customers noticed no issues at all during the June route leak. Without filtering, if you look at the Verizon network, they definitely noticed an issue and lost a ridiculous amount of traffic. And maybe we can all cheer for you when you deploy RPKI route origin validation, just as Job Snyder celebrated when AT&T deployed RPKI validation, or how Telia was able to celebrate being the first tier 1 operator to deploy RPKI route origin validation and dropping invalids. So as a summary, I hope over the last 25 minutes I helped you understand that the Verizon route leak incident, and have shown what we as a community of network operators can do to prevent this from happening in the future. If you have any further questions, please don't hesitate to either send me an email at tstrix@cloudflare.com or just send me a DM on Twitter at tstrix with any of your questions you have regarding any of the things I've just said. Either way, I hope you have a very pleasant day for the rest of your day, but please stay safe and wash your hands.